Alright guys, welcome back. We're in 13.4, translations. Snow tubing involves sliding down a snow-covered hill on an inflated tube. As you will see in example 1, you can use a translation to describe a change in a position of a person sliding down a hill. A transformation is a change made to the location or to the size of a figure. A new figure is formed by a translation is called the image. So you start with your original graph. Once you move it up, down, shrink it, your new figure is called the image. In this book, the original figures will be in blue, and the new figures, called the image, will be in red. Prime notation is used to identify the image of point A. As you read, A with that little apostrophe is called A prime. So when you put the little apostrophe thing right there, it's called A prime, and you use that to indicate your new points. So you're going to have your original A and your new A after you move your figure. Your new A is called A prime, and it's going to have the little tally by it. A translation is a transformation in which each point of the figure moves the same distance in the same direction. In a translation, a figure and its image are congruent, meaning they're the same size. Nothing is changing there. We're actually going to skip example 1, and we're going to look at these checkpoints as example 1. Describe each translation in words. So we have two figures. Step 1 is to identify which is our new figure, which is our old figure. Our new figure is called the image. They tell us here that in this book, the original figure is blue and the new one is red. So here's our new one, or here's our old one, here's our new one. Here's our old one, here's our new one. And we're told to describe the translation in words. Well, remember, the translation is just moving the figure. We're asked to describe how our first figure moved to the second figure. How is it that we went from here to here? What did we do? Well, it's best if you start with a particular point. If we look at our original A, what had to happen in order for A to become A prime down here? How did it have to move? And you just quite simply count it. So what did we do to go from A to A prime? Well, we went down 1, 2, 3, 4. We dropped 4 units. From here, 1, 2, 3. Oops, we actually just went down 3 units. Again, 1, 2, 3. So our first step is to describe how we went from figure 1 to figure 2 is we drop 3 units. And you'll notice that for each of our points. What about from C? How did we go from here to this line? We're going to drop 3 units. 1, 2, 3. What about B, which is originally here, to B here? 1, 2, 3. So describe our translation. Well, we go down 3 units for every point. And now how did we go from here to here for A? We walk to the right how many times? 1, 2, 3, 4. To go from A to A prime, we had to go to the right 4 units. So how do we describe this translation? We took every point, moved every point to the right 4 units, and then we moved it down 3 units. We're going to do the same thing here. How did I go from E to E prime? Well, let's do our left-right first. How did I go from here all the way over to here? Well, I walked to the left 1, 2, 3, 4, 5, 6, 7. I think I miscounted. 1, 2, 3, 4, 5, 6. There we go. I walked to the left 6. And now that I've walked to the left 6, how many times did I have to go down? 1, 2, 3, 4. So how do I describe this translation? I took every point and I took it 6 units to the left, 4 units down. But there's a rule. So rather than just having to walk them out each time, there's a rule that we can memorize to help us. Coordinate notation. You can describe a translation for each point. So every point in your graph has an X and a Y value. And if we want to do a translation of a figure using the coordinate notation, whatever we do, we have to just look at it and say, X is being moved or subtracted a certain amount. So we're taking our x value and we're adding 6 to it, or we're subtracting 6 to it, whatever our a value is, and then we're going to take our y value and we're going to add or subtract a particular value to that as well. And that sounds confusing right now. I fully get that. But let's look at these. I hope your book is open because that way you can see this a little bit better. We're going to explain our x and y right here as it gets added and subtracted to a and b through looking at this picture. So, one more time. You can describe a translation to each point, x and y, of a figure using coordinate notation, where your x and y becomes x plus a, y plus b, where a indicates how many units a point moves horizontally. So if we're at x, we're adding or subtracting a. That tells us how far our original point, so if we had an original point right here, adding or subtracting a tells us how far we have to move it to the right or to the left. It's our horizontal change. B indicates how many units we have to move it vertically. So if we're adding or subtracting b, it tells us if this is our original point, how far up or down we have to go. And hint, if we're adding, we're going up. If we're subtracting, we're going down. Now, move the point xy to the right if a is positive and to the left is a if a is negative. Move the point up if b is positive and down if b is negative. So let's look. They have this figure that I'm now going to draw out. Remember, blue is our old image, red is our new. So they have this point at -1, 2. So -1, 2. We're ignoring that. And then they have another point at -3, -1. -3, -1. And this was their first image. And again, we're just looking at the graph at the top of 730. And then they have the second image. This is point B, this is point A. And then they give you a B prime, which is 3, 1. 1, 2, 3, 1. And this is B prime, so our new one. And then they give us an A prime of 1, -2. 1, -2. And that's A prime. And now, if we wanted to go back to this rule and fill it in, we say, okay, what was my original x value for each of my points? Again, this is just repeated for point 1. And then we're going to do it again for point 2. So it's not, this will solve all of your problems. But okay, looking right here, what were our x and y values, and what did we have to do to adjust them? So now we're going to fill it in. If we're looking at B, how far did I walk to the right or to the left? Starting with our x value first, which is horizontal. If I was originally here, and my negatives, what did I have to do to end up here? I walked 1 unit, 2 unit, 3 unit, 4 units. I walked 4 to the right. The right side of our graph is always positive, so I took my x value and I added 4 to it. Again, what did I do for my b value? To be here at 2, to end up here at 1? Well, I had to subtract 1 to end on this line. I went down 1. So what did I do to my y value? I subtracted 1. And now this is our rule. For every x value, we add 4 to it. For every y value, we subtract 1 to it. Now let's double check it with this one. We know that if I were to apply this rule to this graph, I would end up with a new point. They've already graphed our new point, so by following this rule, we should hope to land right here. It says take your x value, add 4 to it. So my x value is my right left value, so I'm going to walk to the right 4. 1, 2, 3, 4. Now it says take my y value and subtract 1. My y value is up, down. So if I'm subtracting 1, I'm going to go down 1. And my new point would be right here, which is exactly as it's already drawn. So this rule proves to be correct for every point on this line. Let's look at example 2 now. Translating a figure. Draw triangle ABC with the vertices A as 3, -4, B as 3, 0, and C as 5, 3. So I'm going to draw that out. Example number 2. I'm just kind of eyeballing this. Doot, doot, doot. And now they tell me my original A is going to be 3 comma negative 4. 1, 2, 3, 1, 2, 3, 4. And it's super important to label, that way you know where you're at. So I have A. B is 3 comma 0. 1, 2, 3. Yep, that's good. All right, 3 comma 0. That's my B value. And C is 5 comma 2. 1, 2, 3, 4, 5, up to 1, 2. And now this is my original triangle, and they're gonna ask me to move it. Just a surefire way to know that. That's my original figure. And now they say, find the coordinates of the vertices of the image after the translation x, y. I'm gonna write it down. They're saying this is your rule of what you're gonna have to do to every coordinate. X, y is going to become x minus 6, y plus 2. So I'm going to make this translation to every single point. Now you have the choice. We know that A is 3 comma negative 4. So you could say, okay, if x is 3, 3 minus 6 is going to be negative 3. So point A, we're just going to do it this way really fast to just show point A. So if point A originally was 3, x minus 3, x is 3, 3 minus 6 is going to be negative 3, y plus 2. Well, my original y value is negative 4, so negative 4 plus 2 is going to be negative 2. So that's going to be my A prime position. B prime, well, my original B that they tell me is 3 comma 0. So take your x value minus 6. My x is 3. 3 minus 6 is going to be negative 3. My y value is 0. So 0 plus 2 is going to be positive 2. That's my B prime value. And my C prime value originally was 5 comma 2. So if x is 5, 5 minus 6 is going to be negative 1. And if my original y value is 2, 2 plus 2 is 4. So I went mathematically and found all of my points, and then I could graph it. Or you can take each point and walk it over. So again, you have all your points, you could now go and graph it. Alternatively, you could say, all right, here's my original A value. I need to subtract 6 from it, which means walking 6 to the left. And then I'm going to take my y value and add 2 to it, which means going up 2. So here's A, and I'm going to walk to the left 6. 1, 2, 3, 4, 5, 6. But that's not actually my point. So that's just walking to the left 6, and now I'm going to take my y value up 2. 1, 2. So this right here is my new A prime value, which is exactly what I said it would be. Negative 3, negative 2. 1, 2, 3, 1, 2. So you can do it mathematically of writing it all out, or you can just walk each point over. For B, I need to subtract 6 to it, then add 2. So I'm going to take it and walk it to the left 6. 1, 2, 3, 4, 5, 6. And now I have to add 2 to it by going up 2. 1, 2. And just like I said, it's at negative 3, positive 2. 1, 2, 3, up 2. So now I have B prime. I'm going to do the same thing with C. I'm going to walk it to the left 6, up 2, and I'm going to end up at negative 1, 4. So I'm going to walk it to the left 6. 1, 2, 3, 4, 5, 6. And now I'm going to walk up to 1, 2. And I'm going to end just where I said I would at negative 1, 4. So that's C prime, and here's my new image. My image didn't get bigger or smaller. All it did was move to the left 6 and up 2. We'll do one of the checkpoints together to just make sure we really get it. So for checkpoint number 3, I'm going to flip the page. So, checkpoint number 3. Draw the quadrilateral JKLM with these particular vertices. So, I'm going to draw out my graph again. Boom. Negative 5, 0. So 1, 2, 3, 4, 5, and that's J, and it's at negative 5, 0. I have K at negative 2, 0, 1, 2, negative 2, 0, and that's K. Then at L, I have 3, negative 4, so 1, 2, 3, go down to negative 4, 1, 2, 3, 4. That's L, and we're at point 3, negative 4. And then for M, negative 2, negative 4. 1, 2, go down to 4. 1, 2, 3, 4. So it's definitely an interesting looking little figure, but that's okay. So now this is letter M, and it's negative 2, negative 4. Draw out your line so you can actually see your figure. Boom. And that's what it looks like. And now they tell you to apply a particular rule. Find the coordinates of the vertex of the image of the translation, and then they tell you this is your rule. XY is going to become x plus 7, y plus 4. Easy enough. So we're going to take J, and we're going to make it J prime. So if I originally had x is negative 5, well, negative 5 plus 7 is going to be negative 2. If my y value is 0, y plus 4, so 0 plus 4 is 4. We're going to go down to K.